Hello, welcome to day 2 of the NEM event hosted by Centennial College. My name is Ashna, and I'll be one of the hosts here for you in today's call. We have a very exciting event planned for today, and I have incredible speakers here who will be sharing their stories, who will be sharing their research, fascinating work in the field of biotechnology and other science-based careers, science, technology, engineering, and maths. So right before we begin that, I'm going to share my screen with a little bit of what we have planned today. As I mentioned, we have our speakers who will be talking about, one moment. We have our speakers who will be talking a little bit more about their journey at Centennial, and they'll be talking about the interesting research work that they've been doing recently and sharing more about how this work will pan out in the future. So without giving away too much on that, I will allow them to begin and introduce themselves. But during the course of this event, we also have, and I hope that you can see my screen right now, we also have prizes for the duration of this call. Each of our speakers, as I mentioned, will be talking to you a little bit about their subject matter. At the end, we have questions for those who are paying the most attention or those who have, whether you're the most engaged or you end up winning prizes. We'll be asking you questions as the question answer session goes on. It can be through the event and a couple at the end as well. These are the prizes that you have the option of taking home with you at the end of the session. These include, as I mentioned, Centennial College is one of the hosting members of this event. So you'd be able to come in person into our fully, what's the word I'm looking for? Into our complete labs and have an in-person tour. We also have the option for a virtual walkthrough of our college labs. We then have a mentorship program where the participants have access to having a mentorship done by a college student who can guide them, whether that's career, whether that's advice, or whether that's just, I don't know what step is next for me. And having this student to student relationship, I personally feel is very valuable because I've been on both ends of mentorship, whether that's with students, with tutors, or with teachers themselves. And of course, we have gift cards during this event. So this is completely up to your choice. We have multiple $15 value gift cards, and you can choose whether that's Amazon, Cineplex, iTunes, or any other store of your choice. And this is my personal favorite, which is you get a lab coat that's personalized for you that you get to use, and it'll be shipped to you in the mail. So without further ado, I'm going to pass this on to Nisha, who will take over from here. Hi, Nisha.
Thank you, Ashna. Good evening, everyone. I welcome you all in the NEM event. My name is Nisha Rani. I'm going to introduce the speakers who will be hosting the seminars today. Firstly, I would like to hand over to Elisa, who is going to speak on dry cell batteries using tuna bio-waste. I would like to hand over to Elisa. Thank you.
Hi, Nisha. Hi, everyone. Thank you so much for having me. So I'm very honored and grateful to talk to you about this project, or this topic rather. This is one of my projects when I was in high school. So is it okay if I share my screen right now?
Yes, you can share your screen.
All right, thank you so much. Hold on just a bit. Sorry, this is taking a bit.
I see that we're having some technical issues while we share the screen. So thank you for being patient with us as we figure this out.
Elisa, sorry, we are not able to hear you. So I would like to move on to the next while Elisa is figuring out. So I would like to present Sparsh. So he would be the second speaker. So he would be talking on antibiotics potential activity of Sorantia alba, which is commonly known as mangrove apple. I would like to hand over to Sparsh. Thank you.
Good evening, everyone. I hope you are doing well. Today I'm presenting a presentation on antibacterial potential of Soneraceae alba plant. First of all, we need to understand few things before going into our presentation. The first thing which I would to ask you, like, have you played a whack-a-mole game in your life? Whenever you go to any rec room or any game zones, you just see this game whack-a-mole. So if you have played that, just tell me yes in the chat. Whack-a-mole game has a similar concept to the antibiotic resistance mechanism. So what's that? So in a whack-a-mole game, you know that whenever the moles pop up, it's very slow in the speed. So you can easily hit them and you can kill them. But as the speed increases, you cannot kill the mole easily. Similarly, in antibiotics works like that. So if a bacteria is not evolved or not mutated, you can easily kill them. But as soon as it gets mutated and evolved, your normal antibiotics won't work against the normal microorganisms like normal bacteria. The same case happens, and that leads to the antibiotic resistance. So for that, you need an alternative cure about the antibiotic resistance. And first of all, uh, I want to say that Soneraceae alba, which was decided by the researchers to carry out, which was has antibacterial potential activity, and that's what we are verifying in this research activity. So Soneraceae alba is a mangrove plant which is mostly found in tropical regions, and the methodology which they followed. First of all, they cultivated the two microorganisms. That was first E. coli, as we all know that, and second was S. aureus, which I have showed in the image. And they dipped the filter paper. They used the filter paper, which has a different extracts of the Soneraceae alba. So that is bark, fruit, and leaves. They prepared the three different extracts, and they dipped the filter paper in that, and then impregnated that disc in this various zones of that petri dish, as I have shown in the image. And they just incubate that dish for 25 degrees Celsius and 24 hours, and then they observe the area in which the microorganisms which were not present. This area is particularly known as a zone of inhibition. So what results they found? So when the results came out, all the three extracts showed the positive results. But however, the fruit shows the highest zone of inhibition, and all the extras shows the property of the bacteriostatic, and which was great, right? Because they stopped the growth of the bacteria, but that was not a bactericidal. And amongst both of the microorganisms, it showed that S. aureus was the most susceptible organisms. So what conclusion we can derive from this? So Soneraceae alba is a better alternative than antibiotics for the antibacterial agents. Yes, we need further research on that, into how this Sonderische alba works, what's its mechanism, and what's the potential clinical applications, what's the other side effects if we do this, if we give this medicine. So for that, we need further research as well. And this study, which finds our objective to find the antibiotic potential, so it totally matches with our studies. And also, it also confirms the antibiotic property of this Sonderische alba. And I hope you understand all this topics very well, as I think it might be a higher level for you. But if you have any questions, you can ask me anytime. Thanks so much.
Thank you so much, Spurge, for giving us the valuable piece of information about the antibacterial properties of Soneraceae alba. It is good to know that Soneraceae alba has the antibiotics potential. So may I ask you one question? So what's the difference between the bactericidal and bacteriological properties of plant?
Sure, Nisha. So generally, to prevent the growth of microbes, we have two properties. We have two mechanisms through which antibiotic works. The first is the bacteriostatic. And what's the meaning of bacteriostatic? The bacteriostatic states that it stops the growth of the bacteria, while bactericidal activity shows that it kills the bacteria. In bacteriostatic, you won't kill, you just stop the growth of the microbes. That's it. That's the difference.
Thank you so much for clarifying that. Spurge will be open to any questions if you guys have. Thank you. I have got one more question, Spurge. So can you tell us about the studies?
Yeah, so I'm currently studying in biotechnology fast track first sem, and I saw one more question of Prof. How abundant is plant and easy to access? It's easy to access as it's mangrove plant and also grows in tropical regions. So for as far as the geographical region, you can say that it grows very well and it's found in very much tropical regions of the world. So it can be easily found anywhere in the world.
Thank you so much. So I would like to move on to the next presenter. So next presenter would be Rohan. So he is going to introduce the biotech contribution on the stem cell research. I would like to hand over to Rohan. Thank you.
Thank you, Nisha, for this opportunity. And good evening, everybody, and hope you all are doing well. So today I'm going to share the details about the biotechnology contribution to stem cell. So just give me a minute. Okay, just Nisha give me the one thumbs up. So is it a good and audible? Okay, thank you. Okay, so as you know, like what the stem cells is, when the embryo develops, like in the initial stage of embryo, it converts into the blastocyte, and the blastocyte contains some inner mast cell which has the potential to convert itself into the any body cells which is needed to. That's why it's called the stem cells. If you see, the stem cells are the undifferentiated cell, as we all know the basic. If you see like this, the stem cell is like a able, like you see the graphics, like the stem cell can be anything which they want. For the skin, it can become a skin cell to protect our skin. It can become the muscle cells, which can provide us get energy, and it can also become a nerve cell to make a neuron connection. So that's why if you see the stem cell has a great potential and a great portfolio, like whatever we want. That's why it's also been a part of the bone cell, and it's also shown as this as a fat cell in the liver cell. Now, if we go further, like there are two main types of stem cells which have seen in the humans. In the embryonic stem cell, which is one of the initial stage of the stem cell, and then after some time, it becomes into the adult stem cell. Now, if you see like the stem cell in the visual, like the embryonic embryonic stem cell has a great potential Well, as in the initial stage of the embryonic, so it can transfer into the liver cell, muscle cell, nerve cell. But after the somewhat, when it becomes to the adult cell, it's lost is some capability to convert it, and that's why the adult cell is only converted into simple form, which we know as erythrocytes, which is normally known as RBCs, neutrophils, and other immune system supporting things. Now, if we go further, we have the fun fact, like the many body parts, like we all know, the bone marrow and the blood, and even sometimes your teeth also, the baby teeth also carry some kinds of stem cells, which are the embryonic stem cells. That's why the today's scientists are doing a great research on the how can extract all the cells and yes, sorry, but okay. Thanks, Brenda. Thanks, Brenda, for your comment. And if you still see the baby is dying, so scientists are also doing some research and some hard work to see the at which stage we can restore it and we can use it as a further research. Now, if you go on the further, the stem cells have the potential to treat a wide range of disease, injuries, and such as a Parkinson's disease and the diabetes. We all know the diabetes, like your body is not able to produce enough insulin to pack up your glucose and convert it to glycogen, and the spinal cord injuries. So now, if you go further, the stem cells have, as I talked before, like the stem cell for example, if the liver cell is not working properly, so the initial stem cells can go to their place and make another cell. That's why it's called the regenerative medicines. And now the doctor and all the scientists are working together to treat some disease like leukemia. If you see that now, like the bone marrow, we all know the bone marrow contains of the cells which keep continue making a blood test in every 120 days. But somehow it's scared to cancer, it's converted into cancer because of the uneven growth. Now it's a very dangerous to the person's health. But because of the stem cells, we can replace these cells and we can again make it to again make it workable so that the human can make their self more reliable. If we go further, then because of stem cells are the promising area of the research and development in medicine in the because of the contribution of the biotechnology. Like for an example, if we all live in Canada, we all know like how cold the weather, when the weather goes cold, the oxygen level is get feet up down. That's why if you see the person with a high pressure, his hormone in the kidney releases some hormones which give it a signal to the bones to create more and more blood cells. So that's why they can contain more oxygen, so that the human can keep their homeostasis and be in a very position where it's keep it healthy. Now, the scientists are doing the exactly same thing for the same cells. Like they are creating organisms, they are recording things, they are also making some meat and some of the organism in the petri dish. Now this is the great discovery for the biotechnology because just think about it. Right now, to create a bunch of meat, we are breeding the animals. We are also cultivating our crops and to feed that animals. And there is a lot of transportation on all things. But think about that in the future, if because of this cells, we can create all organisms in the petri dish, and we can make a particular organism, not just like a whole body. Now, if you saw, like, there are some challenges and controversy as we go into the deep knowledge. Like the stem cell can grow, divide, and rapidly, which if somebody does not control their control their position, then it could also lead to the tumor. So that's the main thing of the stem cells. Like you have to make it and you have to make it workable in the proper manner. So if you see as such include the immunity cells, which are made from the adult cell, had to be in the reprogram. Like as I mentioned before, there are some cases of immune rejection into the further research. Like there is sometimes, uh, that the donor stem cells does not accepted by the the host one. So it could lead to the immune rejection. That's why the people of the current era, especially in the Western world, which are rich people, are storing the stem cells like the backup option. I know, like they are paying them almost $1 million to keep their cells in the stem banks, and there are so many banks which are keeping this kind of thing into their very great and highly facilitated storage, which can be used in further, which we can use in the further life as they grow up. Now, with the drug discovery and the now if you talk about the drug discovery and the basic research. Now, stem cells are being investigated as a potential treatment for the neurological disorder, such as Parkinson's disease, Alzheimer. As we all know, the Alzheimer, the neurons keep breaking the connection. That's why they have the habit of not passing the message to the each neuron. And there's multiple sclerosis also the one of the example of that. Now, researchers are exploring the stem cells can be used to replace damaged neurons and promote the regeneration of the neural tissue. As we all know, after some age, the neurons can't be grow. So that's why that's the more main question when it comes to the brain research thing. But because of this great discovery, now we humans are able to make the brain cells and examine it in the the meantime we are using this kind of machine, and though we're using this machine, we can't just go deep down to the brain and take the cell out. Because if for the taking the cell out and studying it, we have to cut through the brain. But because of the new technology of this human study, we are now able to take out the neuron and create our own neuron into the petri dish. You see, because you see, the primitive stem cells have the ability to make whatever cell they want. So that's why we can make our own cells into the culture with exactly identical to what the brain cells is facing the problem. That's why, and because of the genetic thing, we can also make a difference between which is the healthy cell and which is the going the disease cell. Now, this kind of discovery by the biotechnology has great opportunity to all the person and all the pharmaceutical company to make what kind of drugs in the particular area of the brain. Now, this is how I want. This is the whole thing about the stem cell. So, in the my short, as I know, like we all are in the age of the very younger age. So we all are stem cells, while we are all cells. So that's why I always say, like we all are the stem cells that we at the very current age. So do the whatever you choose and do the whatever you make you excited and which makes you keep learning about new things. So thank you for this very opportunity, and I want to thank my all the participants and especially professor. So thank you.
Thank you so much, Rohan, for sharing the valuable information that would be extremely beneficial to know. I hope that the audience will be able to understand the concept behind the stem cells. So I have got one question for you. So would you like to answer that question? So the question is, you mentioned the term pluripotent. So what does that term exactly mean?
The platform is it you say like it's one of the initial stage. Like there are some cells which can reproduce and which can take the place of the disease cell. That's a one cell of the categories, which is which we are really told that. Now that's exactly the primitive cells converge comes from.
Thank you. The question is, what sort of research is being done on stem cells today?
Mhm. As I mentioned before in my PPT, like right now the brain is the main thing which they are doing. If you see like the past and the current time, people believe like after certain age the neurons does not divide themselves and they are just being the constant in the brain cell. But right now, after some research, the scientists has found there is a one area in our brain in the backside of the hippocampus that there still have some stem cells of the brain which can convert into neurons. And this is the main research going on right now. And how and the other question which I can see is that how can I enter into this industry of education or certification? Uh, I don't get a question like for the especially for the neuro thing or the stems.
I think that question means like, if you want to do the stem cell work or you want to participate in the
Oh,
stem cell research, what education and what the certifications are required basically to be a part of this research.
okay. Now as I seen the research when I seen all the person who is doing it right now who is working on this then so everybody the person you have to go to pharmacology. You have to first understand how the human body and the human immunology works. That's after there's a stem. That's after stem come and that's the one part. So I think the pharmacology is the main thing. After then, you have to do the medicine and some idea of the stem cells. So yeah, that's how the pathways goes for the stem cell studies.
Okay, thank you, Rohan. So now I will move to another presenter. So Elisa, are you ready? So she's going to talk about the topic, which is dry cell batteries using tuna bio-waste. I would like to hand over to Elisa. Thank you.
Thank you so much, Nisha. Can I be heard now? Is it all good? Yeah, sorry for the technical difficulty. I'll be sharing my screen. Okay. Can you see my screen? All right. So once again, hello, everyone. I'm Eliza Gargoliano. I'm an international student from the Philippines, and I'm currently in my second semester in the biotechnology program of Centennial College. So it's an honor to talk to you today and share with you one of my projects that I did during high school, along with my fellow researchers. So to begin with, ever since I was a kid, I've always had an inclination for science. I've always done like little experiments back home and eventually evolved into actually doing some research with the help of my research advisor as I got into high school. So what I'll be talking about with you today is one of the projects I did with my fellow researchers that's on making batteries out of tuna bio-waste. So first of all, when we look at these objects, what do you guys think they have in common? Like, how are they powered, basically? You can chat down your answer or if you want to respond, and I'll see them later. But in general, they are powered by batteries, like dry cell batteries, the ones we use for these devices, right? So why am I talking about batteries? During this time, when we were making this project or when we were thinking of making a research or digging something up, we thought, hey, the Philippines had this really bad power shortage dilemma. So we were like having blackouts and power shortages, or rather power outages everywhere. Sometimes that will last around minutes or even at days on end, and sometimes just hours. So we thought of this dilemma and we were like, hey, what if we do something about this dilemma? But we were like, we can't solve the electricity crisis overnight. So as a meddling, curious bunch of students, we thought, hey, what can we do about this that's feasible? Something that we can just do and not like at a big scale project. So we thought, hey, what if we did something like batteries? Because batteries are small, they're feasible, and they're very useful in our daily lives. They can power up flashlights, they can power up our devices, and even some materials that we need just to get by, especially in power outages. So we thought, hey, this is possible. This is small and it's useful too. However, we didn't just want any battery. We wanted our battery to be something different, something unique. And most importantly, we wanted it to be less toxic than the commercial ones that we are using, because we already know that batteries contain toxic chemical content or chemical waste that contribute to ecological waste when disposed inappropriately or just like thrown everywhere. However, we thought, how do we make it into something different? How do we make it eco-friendly or somehow less toxic? So we thought, we're living in the tuna capital of the Philippines. So our city is the tuna capital, and we had a bunch, or rather tons of tuna laying around in the port. Some are processed and some are discarded. What if we use the tuna? We then found out through a bit of research that parts of the tuna, like the innards and the skin, as well as the fins and the tails, contained heavy metals like copper, cadmium, and manganese. which can generate direct current voltage. So what if we use that and use it as a power source for our batteries? Then we drew up a plan on making our batteries with the tune-up parts we could get from our local port. So this is what we did in general. We collected the tuna biowaste, and we were pleasantly surprised to find out that these biowaste, like the guts, the gills, the tails, the innards, they were all discarded. Like it's not used for any processing at all. No one's gonna eat them, no one's gonna use them, so they are just thrown away. We were like, let's make something out of this because it's such a waste and it has so much potential. So we got all of this for free. It smelled a lot, but we got this for free. We then we let it dry first and grinded the biowaste as well as charred it so that we can activate the carbon and attract electrons, which can then generate direct current voltage. Just a bit of a background, when we were doing this, we had to do this at least 3 times over because every time we had to like grind it or char it. Tuna stinks when you're trying to like burn it. So we had to air out the lab. And since our lab was underfunded, we didn't have enough equipment to like filter out all of those smell and filter out any of like contaminants. So when we went back the other day to like put them in the batteries, we found out our tuna biowaste were being laid on by flies and there were maggots everywhere. So it was a crazy experience and we just had to like clean everything up, disinfect the entire lab, and we stayed for a week just disinfecting and just doing it all over again. So we then proceeded to build the battery finally after how many tries. We just recycled the parts of the batteries we needed, like the ends, the rubbers, and the carbon rod in the middle, and disposed the inside of the battery appropriately. So we didn't dispose it like anywhere. So we made sure that we were able to dispose it appropriately in our local town's regulation. So we took off, or rather we removed the powder in the middle, and then we added our charred tuna, and then added a bit more ingredients that I cannot disclose at the moment, and sealed the batteries, which we then finished. And they're double A in size, just to be clear with you all. We then tested out their voltage and their longevity, and we were very surprised that it is actually comparable with that of the commercial batteries that we find in the market. So just to give you a bit of a demonstration, here's a video with a toy where we used our batteries on. So yes, those are our batteries. We wrap them up nicely. Oops. Yes, so we're putting the batteries in. And it was able to power up the toy. This is also a footage where we got interviewed for our project in our local town. So we showed them how the battery was lighting up the fairy lights. Oops, why does it keep pausing? And how the batteries were able to power up the small toy as well in my fellow researchers' hands over there. Right, there we go. Okay, so these are just some of the experiences we got when we were doing our project. So we were able to travel to a lot of places with this project because we had to present them in various competitions and conferences. So one of those was in Malaysia, where we got a bronze medal, as well as in different places in the Philippines where we were able to present them in conferences, as well as learn from other researchers and their inventions or projects as well. So I just wanted to share this experience and this project with the hope that I was able to like engage your creativity and inspire you with this project, and as well as to pursue the STEM field, because I really make it a point that STEM isn't something, and it shouldn't be intimidating to you all. It's actually a very fun and creative field that you fall in love with despite its ups and downs. And I've been doing it for like years now, and it's very fulfilling, very rewarding. It can be tiring sometimes. You have to do the projects all over again just to like get the most accurate and most valid results, but it's also worth it, and it's been a great ride. So I hope you like learned something from this talk, and basically that's just it. I hope, is there any questions?
Thank you, Liza. So I have
Thank
got
you as
one
well.
question in the chat, like, do you also use these batteries today?
Right now, we can't really, I don't use it right now because it's back home. But after the competition and after the entire thing, we got a bunch of batteries left over. So we basically shared it with my fellow researchers. And I think they're still using it today. I have them at home though. I think my parents are using them to like power up the remotes at home and everything, as well as the flashlights.
So the second question is, did you consider pitching these to a bigger company?
We during our Malaysia presentation, we actually were able to speak to a general public. They opened the area for general viewing, and we were actually able to talk to investors who wanted to get in touch with us for our project. However, because we were only in Malaysia for a limited time, we couldn't like have our schedules connected, so we weren't able to pitch our project to them just yet.
So one of the audience members is asking, can you recharge the batteries?
That's actually one of the things that we put in our recommendations in the paper, of finding a way to like recharge the batteries, or like trying a wet cell battery as well as other sizes for the batteries if it's still applicable. Yeah, so we haven't actually thought into that, but that's one of the things we wanted to delve in more. Like, how can we recharge this so that we don't have to keep making more batteries, or like recycling or keeping more of those cans?
Thank you so much, Eliza, for sharing your innovative idea.
Thank you so much as well.
I would like to hand over to Ashna.
All right, thank you guys so much. This has been a great series of experiments. Eliza, you had mentioned earlier, while I have you here, sorry to put you on the spot, but you had mentioned earlier that you've done a couple of experiments. So one of this was, of course, the batteries that you just explained to us. Is there anything else you would also like to share? Anything you've done in other experiments?
Well, I did a little project when I was in grade 4, I think. But I think it was with the help of my research advisor. It's the antimicrobial potential and the antifungal potential of I don't exactly remember the scientific name, but you know those cone snails? Cone snails.
Yes.
Yes, we were able to test their antimicrobial, antifungal, as well as their as well as their cytotoxic properties. And we also did some UV protection tests using sea squirts, the marine organism sea squirts. Yeah.
Okay. That's so interesting. So you had mentioned in this presentation that the inspiration for these batteries came from the power outages you used to have. What about the other
Right.
two, the snails and the sea squirts?
Oh, for the snails, because like in the Philippines, we're a very tropical country, right? So there's a lot of the marine ecosystem is it's really flourishing. There's a lot of marine resources. So in our city, a lot of people eat the cone snails. Like the cone snails, it's a
Okay.
delicacy.
Okay,
Yeah, it's a
okay.
delicacy, and And they keep telling us it has like really good properties that can fend off like um sicknesses, diseases, and all that. And we were like, oh, is that true? Is that true? So we just tested it out, the antimicrobial properties. So we tested, we actually did the disk diffusion assay for this one. The antimicrobial properties as well as their antifungal properties and other bioactivities. This is the same thing for the sea squirts because the sea squirts are like growing everywhere in our city. I think there was a time where there was a lot of sea squirts in the ecosystem and they were trying to get rid of some of those. So we were like, oh, let's try these out because like sea squirts are a bit of in the surface of the sea. So they get a lot of sun and somehow they're thriving really well. So we tested their UV protection potential because in our city it gets to like 59 degrees in terms of the heat index and you need a lot of like protection from the sun. We
Got
also
it.
did like from I think we did one using like the goose like weeds, the ones that look like duck feet. They look like duck feet. Those are like weeds growing everywhere in our city. And then out of like curiosity we did an anxiolytic assay for it, basically something that can reduce or soothe anxiety,
Okay.
like a test for it because it was a lot of the old people in our city. They were like, oh, we drink this, we boil it and we drink it to help us calm our nerves and all of that. So we were like, oh, they really actually help them sleep better and help them like calm down, that plant. So that was my last project before I left for Canada. Yeah.
That's absolutely fascinating. So I have a question for you, for Rohan, and for Sparsh. Thank you again, all of you, for presenting. But how did you come into biotechnology? What was it that inspired you to come into this field of STEM careers? So I think perhaps Rohan, if you'd like to go first.
Thank you. Well, actually, I'm an international student from the India. Like, I just completed my high school and I came from the biotechnology because biotechnology is always a field of the innovative and the unique way to like it gives a new vision to the biology, not just like a medicine, simple one. Just to make your own thoughts and make the outer world best sustainable for the human civilization. And that's the motto. Why that's the reason why I chose the biotechnology.
Okay. And what do you have? You've done some fascinating research. Do you have an idea of where you want to go next once you're done with your Centennial College chapter?
Uh,
Terms of
okay, like right now I'm pursuing the biotechnology. I'm looking forward to complete my diploma, and after that, I'm looking to get a university into especially the neuroscience to field related to neuroscience because I'm so interested in this discoveries of the digestive brains and all the neuro stuff. So I'm looking for the very good subjects for that.
Okay, that makes sense. And of course, that's on par with the presentation you did. Thank you. I asked this because I know that we have high school students in the audience today, and they're in this phase now where you're applying for universities, for colleges, and for programs, and there's a lot of options available. So I ask you because I know that this will help someone that's watching today. So Sparsh, what about you? What was it that drew you to biotechnology, and where do you see yourself going within this field?
Thank you, Ashna. So biotechnology doesn't just it's not a narrow field, right? It's a broader field of you can just go to the food one, you can be a microbiologist, you can be a lab technician. So it offers so many things. So I was more interested in particular research area, which draws me to the biotech, and that's what I'm looking for the future for my now. When I complete my biotechnology program with Centennial, I'm looking forward to go masters to the other universities. You're muted, Ashna.
Sorry, I was saying that's fascinating. Did you always know that biotechnology was something you wanted to do?
Yes, I do. When I was doing my bachelor's over my country, I was fascinated by biotechnology, and I know that I don't want to go move ahead with biotech as I studied well in that. So that's the thing.
Okay, thank you. Alyssa, what about you? Always knew about this field?
Actually, no. I actually did it at first. I was surprised myself that I'm in biotechnology right now, but I'm actually having fun. Like it's one of the most unexpected choice for me because ever since I was like set on getting a medical degree, like being a doctor and all that, I
Really?
was set on that. Yes, so I was really set on that until like at the end of my high school years. Um, a lot of my teachers were saying if you're not, it's not that they're cursing me or anything, but they're like, if you're not successful in getting your medical degree, why don't you consider a career in research? And I'm like, oh, that actually makes sense. I actually tried pre-med like 1 year, one semester before I left for Canada. And I realized that then that no, this is not for me. I realized so far, it's not for me. So I got into biotech because I was like, biotech is something very innovative. It's doing a lot of projects. It's growing a lot, both in industry and in academia. And it's something that I'm very interested in, especially since I like to do a lot of projects, a lot of experiments, and all of that. So yeah, that's how I got into biotech.
That's incredible. Thank you for sharing, all of you. So actually now I think we'll move on and do prizes. Before we start, I'll do a little bit of a test round. I'll ask the questions as you're hearing me now, but respond with your answers within the chat. The first person with the right answer gets to choose the prize. Let me remind you what the prizes are, so you can pick what you like. All right. So let's do our first trial question. How about we pick a number between 1 and 10 and enter it in the chat. The closest person to say what I'm thinking wins. Again, this is just the trial question. Let's go, let's go, let's keep going. Just going through the chat now. Oh, look at people double answering. Okay, okay. I'm gonna end the trial round. It was 8. Let's see who's closest. It was raw power. Yes, raw power. Okay. Now let's start with our actual questions. We'll start with our actual questions, which is number 1, what were the batteries made out of? Elisa talked about her batteries and the process in which they were from the start to the very end, up until the end product. What were they made out of? First person to put it in the chat. All right, Valentina. Tuna throwaways. Elisa, would you give this person a prize? Awesome. Valentina, what would you like to pick? So these are ordered in my priority, what I would pick. And 1 second, where did the chat box? Oh, I see, number 3. All right, do you have a preference? Do you want Amazon or Cineplex or something completely different? It's your choice. A $15 gift card to Amazon. You got it. Okay, I have your details and I will I'll reach out to you at the end of this. Right, as Professor Yvonne and Valentina have a side discussion in the chat about prizes, let's move on to the next question. Now, coming back to our second presentation, I forget, but the question is, what does the term pluripotent mean? Typing it in the chat. What does this term mean? It was answered tonight. A lot of stem cells. That is true. Do you want to elaborate a little bit? Where a cell that is pluripotent can give rise to a lot of different types of stem cells. So you're very close. Raw power. What would you like to pick as your prize? An in-person lab tour. That's actually an excellent option. Our Centennial College's labs are beautiful, and I'm really glad you picked this option. You're gonna have a great time. All right, and our final prize, we will be giving it to the person who is the most engaged in the chat, which I'm just gonna go through this now, who had the most comments, the most questions within the chats. So far, I'm seeing Aryan M has been the most engaged this entire time. One moment, I'm going to find a way to look at the chat and the video at the same time. Give me 1 second. Aryan, so if you can see the prizes, tell me what you'd like to pick, and I'll be back in 1 second. Can everyone see me? Can everyone see my screen?
We will see you, but not the screen here.
Incredible. Thanks, Nisha. All right. So Aryan says he wants the mentorship option, which is an incredible one. We've had mentorship this entire semester going on, and we've heard really great things about the one-on-one mentorship program. So I'm very excited about that. As I mentioned earlier, all of the prize winners, we'll be emailing you after this call, tell you a little bit more in terms of how to communicate this and get this to you. So thank you to everyone who participated tonight. I really hope that this was helpful for you. And to all of our presenters, thank you for taking the time. These have been incredible presentations, and it's really great hearing about things that you're so passionate about. And we have day 3 of our event, of our NEM event, happening tomorrow. And we hope to see you there. The link is the same as the one that you have joined today. We have other presentations for a different audience, but I'm sure you'll enjoy it nonetheless. If you have any final questions, please feel free to drop them in the chat in the next couple of minutes. But other than that, we're free to go. Thank you so much for popping in. I'm going to stay here for a couple of minutes if there's any questions.